is one perk about a quiz on Friday, I guess. Not that there's many. All right, so today, brand new stuff for you. Don't let this scare you, not that it's hard. So obviously, if you remember on Monday, we talked about exponential functions. Exponents, 5 squared, 5 cubed, 5 to the negative 1. All those different values. And the graphs. So today, we're going to talk about logarithms. Now, those are the inverse of an exponential. So what this is all leading us up to is we want to be able to solve equations that have logarithms in them and exponents in them. And again, they're going to cancel each other out. So I might use a log to cancel out an exponent and vice versa. So one of the things we're going to do, and I have a few things up here I'm going to add to it, is we're going to work on converting between the two forms. That's what I'm going to show you today. We're going to do some graphs today, common logs. That's that log button on your calculator, the one that just says LOG. We call that a common log. And then natural log. I've talked about that button on your calculator. That's that LN button. Seems dyslexic to me. LN, natural log. There should be the other way around. But that's that button on your calculator. We're going to look at all of that. Okay, so logarithmic functions. That's what we're going to get into. That's what you have to fill in some things here on your notes. So let b and y be positive real numbers. The logarithm of y with base b, just so you know, we're looking at this right here. So we read this, or we pronounce this, we say this, log base b of y. So that's how you're going to say it. Now, you want to be able to convert between the two forms, okay? Because sometimes it might be easier to work in exponential, sometimes it might be easier to work in logarithmic. So log form, I'm just going to copy down that log base b of y. Now, if I need to convert it into exponential, super easy. You always start with the base, so b. Remember, I want it to be an exponent, exponential form. So to convert it, they're inverses. Basically, x moves to the left, y moves to the right. So x becomes your exponent, and you end up equaling y. So I always you kind of work in kind of a semicircle. The base to the opposite side equals what you have left over. And we're going to practice today converting between the two forms. Now, I'm going to throw it on here too already because I know you're going to see it. It's coming up here. Remember we use that E button on your calculator? You might have a log base E. So don't let that scare you. Of course, E, the base, to the opposite side equals Y. Okay? So just same thing, same process. You're always starting with the base. You might have that Euler number E. Don't let that scare you. One other thing I'm going to add to this. You will never see the expression log base C. They're never going to actually write it log base C because that is your natural log. So you have to recognize when you have that ln, the natural log, it looks like there's not a base on it. Clearly, it doesn't look like a subscript. But you have to realize you're really in a base E on that. That's a logarithm base E. They just write it fancy as a natural log, ln. So looks crazy, but I promise you it's really easy. First thing we're going to do is just practice converting between the forms. There's no solving. There's nothing to do, really. Write the logarithmic equation in exponential form. So you always start with the base. We raise to the opposite side equals what you have left over, 81. And one quick way to know that you have everything arranged correctly, you should have a true statement. 3 to the 4th power does equal 81. I don't have to do anything else, I'm just rewriting it. So same thing on this. I always start with the base, to the opposite side equals what we have left over. And of course, this is a true statement because that's 10 cubed. If you move 10 cubed to the top, it becomes a negative exponent. Just practicing converting. Okay, same thing. The base, 16, to the opposite side equals 8. And I know we love our fraction, our rational exponents. If you type that in your calculator, 16 to the 3/4, it is 8. The 4th root of 16 cubed. Okay, D. Now, this is, I know you want to say tricky, that seems dramatic. You do not have a specific subscript there, but this is where we know our ln is a base E. So it's going to be E, let me click it forward here, think of that as a base E, e to that 1.3, equals, of course, what we have left over for. So that's the only thing you really have to be conscientious about. ln, you're in a base of e. Any questions on those? Too easy. Okay, let's go the opposite. We're going to convert exponential now to logarithm. You can see all of these are exponentials. They have exponents on them. So of course to convert, I'm going to start with the word log. Now your base is the value that has the power on it. Our base is 8. And I just remember they're inverses of each other. So that means 64 is going to come to the left side, 2 is going to go to the right. 64 to the left, 2 to the right. So you just are writing them out. All right, same thing. Log. Now my base would be 9. 27 moves to the left. 3 halves to the right. Yeah. Let's do a couple more. Those are pretty easy. So are these, just kind of some random variables in there. Don't let the fact you don't have a lot of numbers scare you. It's the same thing. You're going to be in a log base n, whatever that happens to be. 10 moves to the left, t to the right. Now, one thing I don't really love about d, I mean, it is an exponential, okay, but I don't like that it's in a fraction. 1 over. So notice I picked up black because before I convert it, I'm going to rewrite this. I'm going to move the e up top, so that's going to make it, I did not write that messy. Come on, smartboard. I'm going to write that e to the negative 4th. And now I'm going to convert it because I need it in exponent raised to a power. So I'm going to have log base e, which I don't love that. I'm going to swap that out in a minute. That weirdo decimal point comes to the left, negative 4 to the right. Glad you made it, Jackson. Okay, so log base e. We never leave log base e in our final answer. That's our natural log, our ln. Got it. And I don't expect you to write that first line of red stuff that I wrote. You can go right to the answer and skip that. I'm just going to put that there so it's in your notes so you know I got it. So any questions on exponential to log form? We're going to be doing that a lot, switching between them. Okay, some different properties that we're going to use, which, God, I love these. These are so easy. Now, remember, you'll hear me say it a million times this chapter, exponentials and logarithms are inverses. They cancel each other out. Just like square root cancels square root. Negative 5 cancels positive 5. Log base a and an a cancels to just the exponent. They cancel each other out. If you have a log in the same base on either side of your equation, just like if you have the same thing on any side of an equation, they cancel each other out. Same thing. Exponential and a log, same bases, cancel. So simple enough, not a lot of work. We just have to remember logs and exponentials cancel each other out. So we're going to practice simplifying some things coming up here. But we got to talk about natural logs because the properties are the same, but we just got to throw them on here. So remember, log base e, you're never going to write log base e. You're going to put ln. We've already talked about that. So just like it says, properties of logarithms are the same. This is a log, exponential, cancel. And ln on either side, anytime you have the same thing on either side of an equation, they cancel. Exponential, log in the same base, ln's really log base e, cancel. So it's really just, we're going to be canceling a lot of stuff out is what's going to happen here coming at us. Okay, so evaluate the function without using a calculator. Well, that sounds fun. Okay, I'm going to do it out of order here. I'm going to actually do b first, just because I think that's a little easier because you don't have the fraction. So I'm going to start with b. So first I'm just going to put 100,000 in here for x and take a look at it. So I'm trying to do this without my calculator. I might need it just a little bit to help me. So it's really what my goal is. Let me click it back here. I want to be able to rewrite that 100,000 using whatever the base is. Because if I can make that happen, I can cancel them out. So I'm going to rewrite that 100,000 as 10 to some power. Well, you might need your calculator for that. I hope not. Clearly, I know it's not 10 squared. 10 squared is 100. What's 10 cubed? 10 cubed. 1,000. What's 10 to the 4th? 10,000, not it. What's 10 to the 5th? 100,000, that's it. Now, if you need to kind of guess and check a little on your calculator to figure it out, so be it. Now, easy. Answer's 5. 10, 10, cancel. That's as wild as it gets. Now, that's why I said I'm going to go out of order, because of course, anytime you have a fraction, we love fractions, it makes it a little more challenging. Same process, log base 16, 1/4. So I am trying to rewrite that 1/4 is 16 to some power. I'm going to put a question mark there for the power, because that's of course what we're trying to figure out. So get ready for that. Now, 16, 4, clearly they're related, clearly, okay? So down here, I'm kind of, a little mental process. I'm like, okay, 16, 4, they are related. What's the square root of 16? Okay. Now, I don't want to write it square root of 16. I need it 16 to a power. Now, I feel dramatic putting the 2 on for the square root, but I'm going to do it. First power. So remember, it's a rational exponent. That's a 1/2 power. But before I put my power in up there where the question mark is, that's in the bottom. So when I go to move it up top, erase that now. When I go to move that 16 to the half up top, it's going to make it a negative 1/2. Holy cow. So I had to go through all of this shenanigans to come up with a lousy negative 1/2 answer. So this is the one kind of tricky part of your homework, well, of this whole section really, is you have to have a quote unquote kind of a number sense. I was like, well, I can rewrite for, I know it's the square root of 16 or 16 to the half, and then when I move it up top, it becomes a negative exponent. That's kind of tricky when you have the fractions. Clearly that one was pretty easy. Most of them were pretty standard like this, but you know, I can't do all easy stuff in here, right? All right, on your calculator. You pull up the calculator. Elliot.
So logarithms eliminate the base of an exponential.
Yes, they're inverses of each other and cancel.
So by exponential, it means the base of an exponential.
Yeah. So you want the log base and the base of the exponential to be the same.
Log base.
The subscript on the log. All right, so on your calculator, well, let me get out of this table here. So you have this very lovely log button on your calculator. Notice there's not a little subscript on it. There's no base written on the key. But if you look above it, it's got that 10 to the x, that is its inverse in exponential form, base 10. So your log button is implied in a base 10. If it's base 10, you don't have to actually put the 10 on it. You can just write the word log. So that's what all of this is about here. So common logarithm, that's this little fancy name, a log with a base 10. So again, if you just have the word log, you have to know it's in a base of 10. Now, nice and easy, you've got the 10 on here, we can just use our calculator. So you're going to hit your log key and hit 4/5, obviously. And we do the same thing over there. I'm not going to type in every one for you, but let's type in this guy. So log button, 4 divided by 5. You don't have to close up the parenthesis, you can, it doesn't matter, it won't change it. So I'm going to round that to 30. So negative point, let's go 0.97 for that. So easy enough, but you just have to keep all the calculator keys straight. Now, same thing, you've got your 1.9, hit your log button, and then 4.3. So you try that one, punch that in. Clearly I gotta look, I don't have the decimals memorized. Round to 3. Then we have to round to 3. I like that some of you are writing out all the decimals. All right, what do we got? 1.2. 204, got it, okay. Anybody need me to punch that one in? Gotta love the calculator problems. Nobody ever gets those wrong. Okay, now, more simplifying. Again, you're gonna hear me say a million times, logs and exponentials are inverses. They cancel each other out. So, I really like A, because you have a log and the same base on either side of your equation. Just like anything, you have the same thing on each side of your equation. They cancel. Now that just bothers me. I like it x equals. And just to throw some geometry at you, I'm going to use my symmetric property of equality from when you wrote proofs. Remember? Looks on your faces are super fun. That's called symmetric property of equality. Can't help myself. Okay, B, I see x is already isolated. I just have to simplify. Log base 6, 6 to the power. Logs exponentials cancel. 2 equals x. And I'm going to use my symmetric property of equality. Remember symmetric reflexive transitive? Okay, good talk. Everybody loves geometry, I can tell you. Do you remember what CPCTC stands for? So close.
What?
Corresponding parts of congruent triangles are congruent. All right, your log base 7s cancel out either side. X equals 16. Got it. 4 squared, I'm making it 16. Got to love it. Any questions on those? I love this stuff. I could do this all day. Okay, use properties of logs to simplify. All right, I'm on. Now, exponential, log, same bases, same deal. They cancel. Just like square root cancels squaring, they cancel. Now, I'm going to do a little bit of work on this one, a little bit of work, because I don't like this 16. I want it 4 to some power, and 1/4, I mean, whatever, I'm just going to roll with that for right now. So first thing I'm going to do is rewrite 16 as 4 squared, because we need our bases to be the same. Now, easy enough question for you. What is the operation between the 1/4 and the log? Yeah, so we have to do 1/4 times 2 for our final answer. All right, fraction masters, that's an easy one. What's 1/4 times 2? All right. Okay, easy enough. Log, exponential, cancel. ln is your log base e and e, so they cancel. Now again, dramatic here, our operation between 7 and the ln is multiplication. 7 times 0. 0. Got it. All right, final one. E, ln, cancel. ln's log base e, 22. All right, so take a look at those 4. Any questions on those 4? Hit me, Elliot.
How does it cancel when if one is in the exponent and the equivalent is the base of the exponent, or if they're being multiplied together, how can those both have the same result?
Are you
usually numbers
like which one are you looking at specifically?
like C and D?
So what is your what do you ask me for C and D?
Why does ln multiplied by E cancel?
Oh, because
Well,
remember
E
from the
to
beginning.
ln also cancels.
Let me click it back here a few slides, Elliot. Oh, I went too far. Remember, your ln is your log base e, so that e in an ln, log exponential form, I'm going to get further ahead here. Your log and exponential form are going to cancel each other out.
I know. It's just that it confuses me that the operation could be because e multiplied together ln number of times cancels, while multiplied by e also cancels.
So ln and e would cancel to a 1.
Cancel to a 1. So wouldn't that be because it's e to the ln power, right?
E to the ln power. Yep, those cancel each other out because ln, remember, is really a log base e.
No, I get that. I'm just.
I feel like we're talking in circles here.
I don't understand why multiplying it together and setting one to the exponent of the other has the same result.
Multiplying it together and setting 1 to the exponent. Multiply.
They just seem like
Where are
very
you looking at
different-
the multiplying, I
They
guess?
seem like very different operations.
Well,
on
one-
number 7.
Are you okay with the ln and the e canceling?
Yeah, I understand that they cancel.
Okay.
It's just usually there's a specific operation that you have to undergo.
Well, you just have the product between them, so then you're just doing the 7 times 0. That's all the 7 matters with you.
The product between them, but I'm just curious as to why the product is why the product is
Why the product is what?
so
Why the product of this turns out to be the exponent?
no, it's because I don't understand why like it's the same as the exponent.
Why what's the same as the exponent? Ellie, I want to answer your question. I just want to make sure we're on the same page here. Okay, food for thought. Think about this. If I asked you, and this isn't on your notes, we're just going to talk about it because it's what's coming up for the graphs. If I asked you what's the log base 5 and negative 25. So remember, just like the last earlier problems, I am asking you, how can you write negative 25 as 5 to some power? Any guesses on what the power would be? Everybody guesses too, but clearly that's not right, right? Because what's 5 squared? Positive 25. Everybody likes to guess negative 2. That's 1/25. That goes fraction. Can you do it?
No, you can't.
You can't, okay? Because even if I want to use a negative exponent, it just kicks you into a fraction form. So there is no exponent I can make happen over there, so it turns out to be negative 25. So what am I telling you?
It can't be done.
You can't do it. So that's going to affect when we start doing some log graphs here coming at you. You cannot do a log of a negative value. So that means that's going to affect your domain, or what you can put into these graphs coming up at us. Now, I wish we had color copy machines. Ellie, when I'm done, I'll get your question, okay? So when we're taking a look here at our very lovely graphs, which I wish we had color copy machines, because the blue is what we worked on Monday, our exponential graphs. Notice the red is what we're going to be doing today. They look very, very similar. Yes, 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 yes. They're always, because they're inverses. We learned this from a previous chapter. Inverse functions always reflect over that dashed line in the middle, which is our identity function, y equals x. So same thing over here, just showing you some different ones. Here you have your blue, our decreasing function. Mine is in red, the logarithmic function. If you fold them over that y equals x line, they will match up. Now, domain is important. That's why I made you think about what's the log base 5 of negative 25. We can't do the log of a negative number. We have to be over 0. Now, again, that's on the parent function, okay? We might have a horizontal shift, which would affect that. I am going to talk y-intercept in a second, but I'm going to switch down to vertical asymptote, because this is kind of a 2 for the price of 1. If I have to be on the right side of 0, that's also your asymptote line. So your domain and asymptote will always be related. If you have to be on the right of 0, 0 is your boundary line. We won't ever cross or touch it. But again, this is for the parent function. We might have a transformation left to right. Okay, x-intercept. You can see our x-intercepts on our red log graphs are 1, 0. That again will change if you have a transformation, a horizontal left to right shift. Now, we are going to sketch these by hand, okay? Can you do them in the calculator? Yes, and I will show you that at a later date. We're going to do them by hand. I cannot do a log base whatever in my head, clearly. So we're going to rewrite them in exponential form. I can do exponents in my head. I can do it all day long for you, but I can't do a log in my head. So that's why we are getting good at converting between the two forms. So let's do it. Find the domain, vertical asymptote, x-intercept, blah, blah, blah. Notice it's in bold, sketch by hand. There is a way to do it in your calculator. And verify with the calculator. We'll do that at the end. So I'm looking at this and I'm like, log base 4 x minus 3. How am I going to do that in my head? I can't. So I'm going to put it into exponential forms. First, I just don't like function notation when I graph. I'm going to rewrite it y equals. Now, in all of our previous problems, I've had the log on the other side. Don't let that mess with your mind. To convert, it's the same thing. You always start with the log, the base on your log, to the opposite side equals what we have left. Now I'm going to do, I wish I would have left a longer blank for this one. I'm going to add one more thing to this or do one more thing to it before I start making my t-chart and getting some values for it. Again, we're used to when we graph y equals, well, I'm scrambling it all around in my head. I want to make this equation x equals. So the last thing I'm going to do really quick, I'm going to add 3 over. So I'm going to write that nice and pretty. Again, I wish I would have had a longer blank on that. I'm going to put it 4 to the y and then plus 3. Because I can figure out 4 to some power, which I'm going to make a t-chart and do for you in a second. And we'll get into the domain and all of that sort of good stuff here. Now, since I'm doing it in my head, of course, in my head, I'm going to put the numbers in for y, because I can do exponents in my head. So just for dramatic emphasis, I'm going to circle y here so you know that's where I'm starting. I'm going to pick nice, easy, small numbers. I'm going to start with 0. What's 4 to the 0 power? 1. 1 plus 3. And I threw that point on there. I'm going to put 1 in. What's 4 to the first? Plus 3. Now, I'm kind of nervous to put 2 in, because what's 4 squared? 4 squared, 16, that he's getting to us in here. 16 plus 3, 19. I can't fit that on here, so forget it. I'm going to try -1. So, fractions, here we go. What lovely fraction is 4 to the negative first, really? 1/4, 1/4 plus 3. Oh, yeah. That's really going to be great for my graphing skills. 3 and 1/4. I don't know. Okay, let's go. I'm scared to put -2 in. I'm super scared. Because what lovely fraction is 4 to the negative second? 1 over. Can I really even try to graph 3 and 1/16? No? Okay. It's just going to keep getting worse and worse. Now, I'm going to draw it for you in a second. But, why I started with the t-chart? We're going to keep getting, if I put in negative numbers, 3 and some fraction, 3 and a fraction, 3 and a fraction, 3 and a fraction. We're on the right side of 3. I knew that before I even started anything because, man, and I drew over it here. I knew we were going to be on the right of 3 because of this. You have a horizontal transformation. We have a shift. When you have that -3 with x, it shifts it 3 to the right, which that's why I knew I was going to be on the right of 3. Okay, it's no magic to it. So when I do my domain, which is going to also affect my asymptote, when I do my domain, of course, I have to factor in the x -3. It's got to be over 0. We can't do the logs and negatives. I'm going to write this super pretty. I knew we were going to be on the right of 3 because of my shift. And of course, there's your asymptote line, which I'm going to go ahead and draw that on before I draw the curve, because it kind of helps me a little bit. Okay, let's draw this. Got it. And then just take a look at your graph. I'm going to give you a second to draw yours. Don't overthink it.
Oh, I did this wrong. That's why.
Maybe overthink it. What is the x-intercept? Just look at the graph. 4 comma 0. Make it easy.
Yeah.
So I had to convert it to exponential because I cannot do a log base 4 at x -3 in my head, but I can do exponents. I will show you how to do it in your calculator after the next one. Wait for it. Okay, so same thing. I can't do log base 3 of x in my head. So I want to put it to exponential. But the first thing I don't like about that, to convert it, you need it to be log of whatever. So I need to get rid of that +2. I need to move the negative over. I want it log equals whatever. So I'm going to subtract 2 over. And then I'm just going to switch all the signs to get rid of this negative in the front. So I'm going to make it -y + 2. So I have a little extra work. So my exponential form. Don't let it scare you. The log's on the other side. It's normally left, but it can be wherever. Always start with the base. To the opposite side. So my exponent's that entire expression, negative y plus 2, equals what we have left. Looks kind of messy, but I can work with that. And again, we have it solved for x. It's x equals style. I'm not going to use my symmetric property and switch it. I'm just going to roll with it. I regret that I have this graph grid up so high. I'm not tall shoes on. Okay, same deal. I'm going to pick nice small numbers for y. We're putting them in for y so I can do the exponent in my head. I don't know. Let's start with 0. Negative 0. That's weird. 0. 0 plus 2, 2. What's 3 squared? 9. Got it. And there's your x-intercept if you want to throw that down on the blank. All right, let's pick a nice other small number. I'm going to try 1. So if I put 1 in here, I'm going to have negative 1 plus 2. 3 to the first. Got it. 3 comma 1. Let's try 2. If I put a 2 in there, negative 2 plus 2, 0. Anything to the 0 power. Okay, so that is probably enough for me to see it here. We're going to kind of take a look at it on our calculator. I'm going to draw it in a second for you. Now, just because of my drawing skills or lack of drawing skills, I guess, how you want to say it, I always like to put my asymptote onto my line so I kind of have my boundary for it. So my domain and asymptote are always related. Careful here. You're only doing the log of x. It's not in parentheses. It's not in parentheses like this guy was. Remember, you cannot do a log of a negative. I had to make sure that whole thing, x minus 3, was over 0. Here, you're just doing the log of x. I just have to make sure x is over 0. The plus 2 does not affect your domain. And that's my asymptote line too. So I like to mark that. And then I'm going to draw my curve. And you guys probably already wrote down your x-intercept. Oh gosh, pretend I hit that point, right? Yeah. And again, no hard and fast rule on how many points you have to put on your t-chart, because some of these grow very quickly. Usually I can draw it over 3 points. Now, let me show you your calculator. So 1, everybody loves to use their calculators on these. 2, this would be a great style of question for a no calculator quiz. Okay, so, God, I love it. God, I love it. So if I were to put these into my calculator, let me just show you where it's at first. So basically you have 3 keystrokes, functions you have to know in your calculator this chapter. We've already talked log key, base 10, ln, base e. Your calculator can do the other bases besides 10 and e on it. If you go in your math menu, and it's like letter A. Now, I'm too lazy to scroll clear down to letter A. I'm going to up arrow. And it says log base. So now it pops those up. So I can put in anything I want, log base 3 of x minus 5. I can do it. Now, if I want to do this graph, let me clear this off. I'm going to get into y equals. Now I'm going to type that in. So my math menu, letter A. And then I'm going to put the 4. Just right arrow takes you into the parentheses. And I'm going to hit graph. And now I'm going to go in my Texas Instruments hatred spiel. Why do I hate the look on that calculator screen? It stops. Is that the full graph? God, I hate Texas Instruments. No. So one thing you have to be conscientious of, if you're relying on your calculator, if you draw me this, I mean, I'm going to take off. That's not the full graph. You have to recognize that it continues on. Why it doesn't draw the full graph, I have no idea, but it just angers me a whole lot. And of course, notice that it does not have your asymptote on it. But if you look in your table, you can get some points. Clearly you can see, remember our domain, we had to be over 3, because that is an issue. So that is why the first value you get is 4. Your domain is x is greater than 3. So that's how you can type those in. But also be proficient at doing them without your calculator, right? Okay, any questions on the calculators? Punching those in. I think everybody's hopefully got